Hey, what's going on, guys? Let's do this problem right here. So we have this four molecules. Let's see how we can draw the Lewis dot structure for these things. So let's start with the first one, CCl4. So first of all, we have to decide which one is going to be the central atom. So here, if you look at this, C is 1 and Cl4 4, and we know that C is going to be in the central, right? So C is going to be in central, and the valence electron for C is going to be 4, since it is in fourth group, right? So here 1, 2, 3, 4, and now what's going to happen is they try to form a stable octet form. So to form that, they has to have 8 electrons, but this only have 4 electrons. So they will share the electron with each other. So that's what going to happen. So let's draw the Cl atom structure. So Cl has 7 valence electrons. So let's start from here. So we always go in the round pattern. So 1, 2, 3, 4, 5, 6, 7. And if you look at this, this one will bond with this one and form 8 electron. Now if you bound this one, now Cl is in octet form. This one has 8 electrons, so Cl is all set. But carbon has now 5. It needs 3 more. So to form that, we arrange the other Cl around it. So that's gonna share with other chlorines. So let's put the chlorine's valence electron. So it's gonna start from 1, 2, 3, 4, and instead of putting 5 right here, because you know this side is going to be bonding, right? So instead of putting 5 right here, I can put the 5 right here. 5, 6, 7. Now this side is capable of bonding with each other. This is, all of the others are paired, and this is non-paired. So this is going to be shared with this one and form the Lewis dot structure. So let's draw the other chlorine. It also has 7 electrons around it. So let's start with here. 1, 2, 3, 4, 5. Instead of put 6 right here, I put here 6, 7. And now we can bond these two together. And we have one more, Cl, and this one also has 7 electrons around it. So 1, 2, 3, 4, 5, 6. Instead of putting 7 right here, I put right here. So now with this can bond with this one. So now we have everything has 8 electrons. If you count the electron, this is 2, 4, 6, 8. So this one has 8 electron. This one has 8 electron, and this one also have 8 electron, and this one also have 8 electron. So this is in perfect octet form, stable octet form. Now we can draw the Lewis structure. Finally, what we do, instead of putting this, we put a line for each bond. So this is going to be one line Cl, and on top one line Cl. So the line represents one bond. It means 2 electrons. And right here, one line Cl, and we have put all the bonds right here, but we have these paired electrons around it, so we have to put that one too. So around this we have 6 electrons right here. 6. Each chlorine has 6 electrons around it, so we have to put everything. So this one has 6, this one has 6, this one has 6, this one has 6. So this is the final Lewis dot structure for this CCl4. So let's do the other one. We have NBr3. So which one is going to be in the middle? If you look at this, N is 1, Br3 is 3, and we can guess that N is going to be in the middle. And how many valence electron N has? N has 5 valence electron. So let's put the electrons around it. 1, 2, 3, 4, 5. So we have put the 5 valence electron, and one is paired already. So the non-paired electrons are going to be bonding with the Br, right? So we have to put the Br around these non-paired electrons. So let's put the Brs right here. Br has 7 valence electrons. So 1, 2, 3, 4, 5. Instead of putting 6 right here, I put the 6 right here, 7, because this one is going to be bonding with this one, right? So if I bond this one, this is going to be like this. And let's put the other Br. It's also 7. 1, 2, 3, 4. Instead of putting 5 right here, 5 right here. 6, 7. So this is going to be bonding with this one. And the next Br, 1, 2, 3, 4, 5, 6, 7. So this is going to be bonding with this one. And if you count the electrons right now, this one has 8 electrons, this one has 8 electrons, and this one also has 8 electrons, and this one has 2, 4, 6, 8. So this is in a stable octet form right now. So this is the final shape. So let's put this one in the final Lewis structure format. So this is going to be N dash Br dash Br. Each dash represent one bond, dash Br, and around it is going to have the paired electrons. For the N, it's going to be just one paired electron, so it means 2 electrons, and each Br have three paired, like 6 total electrons, 3 paired. So it's going to be 1, 2, 3, and each of them has 3 paired. And this is the final Lewis structure for NBr3. So let's see what happens to the HCN. So C is going to be in the middle. C is going to be in the middle. And let's put H right here. And let's put N right here. H has 1 valence electron. So let's put the 1 right here. And carbon has 4 valence electron. 1, 2, 3, 4. And its N has 5 valence electron. 1, 2, 3, 4, 5. And this one, because hydrogen only can have 2 valence electron, that is the maximum it can have, so that's going to be its maximum. And here we have carbon with 3, nitrogen with 5. So what's going to happen here? If you imagine that this electron will pair with this one, and this one will pair with this one, and this one will go and pair with this one. So this is going to form 3 bonds right here, and after it forms the 3 bond, it's going to have 8 electrons. If you count, this one is 2, 4, 6, and these 2, 8. So carbon has 8 electrons, hydrogen has 2 electrons, and nitrogen also has 8 electrons, because this one 2, 4, 6, 8, so 8 electrons. So this is in a stable octet format. So now we can draw the Lewis diagram. So in the Lewis diagram, this is going to be one bond with hydrogen is going to have 1 bond with carbon, and nitrogen is going to have 3 bonds with carbon. And also we are going to have 1 paired electron, so 2 electrons around nitrogen. And this is the final Lewis diagram for the HCN. And that's how we do these problems. I hope you guys liked this video. See you next time.